We are doing derivatives of inverse trigonometric functions. Well, this is basically a formula that needs to be memorized, and in Khan Academy here, they're focusing on the three main trig functions, sine, cosine, and tangent, and the inverse of those. So in this case, it's arc sine or sine inverse, means the same thing. And it's important to note that our x is 4x right here. So that has a couple different implications and layers to it. As always, we should write the formula, try to do your best to have it memorized, and then just check your work if you doubt what you've remembered. So d dx of arc sine, I'll do my best to try to remember it, is equal to, the sign is positive, 1 over the square root of 1 minus x squared. I remember if this is cosine, arc cosine, it'd be a negative right here. This was arc tangent, it'd be no square root 1 plus x squared. So let's go ahead and I'll check on my notes, and yes, I did get it right. So good. Now, the concept here to remember is that 4x is in the x component, or in the x spot right there, so that's a 4x, which means this is also going to be a 4x. And then this is a compound trig function in the sense that we have the, if we were to plug an x in here, we would have to multiply by 4 first, and then we would do the arc sine of it. So that's the layering of it. So I always like to talk about it as peeling the onion. So when we do the derivative, we apply the chain rule here. The first layer of the onion is the arc sine for x. Then the second layer of the onion would be looking at the inside component here of the 4x. Okay, so putting all that together, that means this turns into 1 over the square root of 1 minus, now instead of x, we have 4x. So that would be a 4x right here. That quantity gets squared. I want to make sure my square root goes over it. And then times, so that takes care of the inverse trig, the derivative of it. And then now we're looking at the innermost function, which is the 4x. What's the derivative of 4x? Is just 4. So putting all of this together, I get 4 over the square root of 1 minus. Now remember, the minus is not squared. Exponents only apply to what they're next to. So it's the 4x that gets squared, and that turns into 16x squared. And then I like to make sure my radicals and fraction bars include everything that they should. All right, and then we're just looking at some answers here. All right, looks like it's probably, what's the difference? There's a plus sign, there's the minus sign. So it looks like that's the one. All right, let's go ahead and see how we did. All right, let's go ahead and do one more. All right, arc cosine of negative x over 5. All right, and then they want to evaluate the dy dx at x equals 2. So basically we're doing the derivative of the inverse cosine function, and then we have the secondary composite function on the inside of the x over negative 5. All right, so the first thing I think I want to do is I just want to write this in a form that's easier to do the derivative on. So this would be equal to y equals arc cosine, and remember that can be written as cosine inverse of, now when it's a 5 on the bottom, I want to pull that out front so I can see it as a coefficient. So there's the 5 out in front, or the 1/5 out in front, and we still have our x, and that just makes it a little bit easier to apply our derivative. All right, and then like I said, we want to think about the formula for arc cosine. Do you remember from what I said? Let's write it out and try to do it from memory, and we'll check our work. Arc, oh, it's so hard to erase on this. There we go. Well, not that hard, but just bouncing around. All right, arc, help me with my spelling, cosine of x is equal to, do you remember what I said about the cosine function? The derivative of a cosine is usually negative, so it's a negative, and then the inverse trig function would be 1 over, do you remember what's on the bottom here? Square root, what's inside the radical? 1 minus x squared. All right, let's just check our work. And that is what I have in my notes. Good. All right. So now we're just applying this idea. Our x is the, and when I say x, I'm talking about just when I included in here our input. It's an x. Let's go ahead and call it that one. I think that would, I don't know, would be easier to use. So either one of these is our x's. And then don't forget, we're trying to evaluate at x equals 2 after we've done the derivative. All right. So this is our function now. And now we have dy or d dx of y. So that's the same thing. I'm doing the derivative of this. Do what you do to one side, do the other. Equals the derivative of arc cosine is that formula I just wrote out. So it's a negative 1 over the square root of 1 minus, and instead of x, we have a negative 1 over 5x, or x over negative 5 here. Actually, when I think about it, through my experience, to me, this one's just a little bit more cumbersome to work with. I like this, that form right there. So I'm going to go ahead and use it. Negative x, remember they're interchangeable, the things I wrote. There it is there, and then all of that gets squared, and then let's have my radical and fraction bars cover it. All right. So that's the outermost function that has the derivative times the innermost function. So what's the derivative? And that's why I have this one written down. It would just be the coefficient. So that would be a negative 1/5. Hence the rewriting it to make it a little easier on the brain. All right, so it looks like I'm going to need to simplify this square and multiply this through, and don't forget negative and a negative. All of that turns into 1 over, so a negative and a negative make a positive, so no negative sign out in front. The square root, that 5 is going to be on the bottom still. Multiplying fractions go straight across, so I'll put it in front of my square root sign. That's not a 5th root, that's just 5 times that. And 1 minus, and then all of this gets squared, and the reason why I wrote it is just easier on my brain a little bit. So that's an x squared on top, and on the bottom is a 25. And let me just check my work and make sure everything looks okay, and I think so. So at this time we would say where x equals 2. So that means I'm plugging in 2 for my x. I'll go ahead and do my work over here. So that now gives me dx of y where x is equal to 2. All of that turns into, and this is just one way that we kind of write things when we plug things in this sense, and that's going to be 1 over, we still have my 5, I'm writing it down first, and then it's the square root of 1 minus, and I'm plugging in 2, so that's going to be 2 squared over 25. And notice I got rid of the negative sign right here, got squared. So there's still that negative right there. I don't think I need parentheses on this. Everything looks to be in order, which would be 1 over 5 square root 1 minus 4 over 25. Okay. I've dealt with these before, so let's go ahead and just do our math right here. So this is a 1. I'll go ahead and change that 1 into a 25 over 25. Let me start changing my colors here so I can kind of keep track of things a little bit better. 25 over 25. So this now becomes equals 1 over 5 on the bottom, square root. 25 minus 4 is 21 over 25. Yikes. And they want to use an exact expression. Okay. So I'm reducing this a little bit. I don't want to skip too many steps for you as my students. So now I'm going to go ahead and do it over here. Whoop. Sorry about all the jumping around. All right, so I'm simplifying right now. I got 1 over 5 square root. Square root goes to the top and the bottom on this one. So I'm getting, that's multiply, yes, multiply square root. So that's 5 times the square root of the 21. And the square root of 25 is just 5. So that would be on the bottom of this. All right. So that's 5 times all of this. That's like a 5 over 1. And notice the 5 cancels. See how this blue looks? Whoop, whoop. And looks like we get finally, I want something I can see a little bit better, 1 over square root of 21. 1 over the square root of 21. And 21 is 7 times 3. It doesn't factor or simplify at all. One of the rules in math is what? You should never have a square root on the bottom, a radical on the bottom. They call it rationalizing the denominator. So I'm going to go ahead and multiply by square root of 21. Square root of 21. I have to do it top and bottom. So this now becomes a square root of 21 over 21. All right. So that looks like to be my final answer. And I'll plug that in. Boy, that was a lot more work than I thought it would be. Okay. So we're using our mouse now. It had to give us the square root signs because we can't get exact answers unless we have square root signs. So square root of 21, and all of that gets divided by 21. See how we did? Nice work. Yeah, that was a tough one. So notice, though, the derivative wasn't too bad. It was just kind of simplifying it out, making sure all of our algebra is in order to get through it. All right, I think we're good so far. The rest should be the same. Let's take a look at the next one. Shouldn't be much different. Yes, not much different. Just now it's the arctan. I talked about it. Try to remember what we said, and then we're plugging 3 in at the end.